Hello everyone, Zaid from Z Security here, and in today's video we're going to show you how simple USB devices such as this USB lamp can be used to gain access to computers. So the way it works is once I connect this USB lamp to the computer, it's going to register itself as a keyboard, and then it's going to send commands really quickly through to the computer as a keyboard, and these commands will allow us to gain full control over that computer using my hacking computer right here. So I'll be able to control it remotely even if this computer was in a completely different country. This could be very useful to gain access to targets, so hackers can send this as a gift, pretending that it's coming from a company that the target company works with, or pretending that it's coming from a boss. The user is going to get this, they'll be happy, they got a gift, they're going to connect it to their computer, as you can see here. It's going to register itself as a keyboard, execute commands real quick, and these commands will send reverse connection to the Kali machine right here. So now I can remotely control that computer. We can start with dir to see all of the directories and files in the current working directory. We can do pwd to see where we are. You can do your webcam list and turn on the webcam. I always do that, so instead of doing that, let's do something different just to get you an idea that I have full control over this computer. So I'm simply just gonna go screen share. And this will basically show me what the target screen has. And as you can see now, if I'm gonna just move the target screen and open up something, so I'm just gonna open up the calculator, and as you can see, we can remotely see what they're doing. But the idea is we have full control over their computer, and we can remotely do whatever we want from here. Now, in the rest of the video, we're going to explain to you in details how to convert any USB device such as this lamp to a hacking device and use it to gain access to computers. But before we get into this, please make some noise for the algorithm by smashing the like button. Follow us on social media to stay updated. We share minor updates there that don't make sense to share here on YouTube. And don't forget to subscribe here and hit the bell icon if you haven't done so already, so you get notified every time we upload a video. So for this to work, we're going to need a device that can register itself as a keyboard and execute commands on the target computer that will allow us to hack this computer. Previously, I done this using my mobile phone in this article right here. So I'm actually going to be using this script later on. So if you haven't watched that video, I highly recommend you go back and watch it. You can find it on our website or on the YouTube channel. But in this video, instead of using a mobile phone, we're going to be using an Arduino board in here. You can use most Arduino boards to do this, and they're actually very cheap. You can look for them online. I'll mention some of the cheap, good models in the description. So we're going to connect this device to the target computer. It's going to tell this target computer that I am a keyboard, and then it's going to send commands really fast to the target computer. These commands will be executed, and they will send a reverse shell to the hacker computer, which will allow the hacker to remotely control that computer and do whatever they want on it. Now, as you've seen in my video, I actually did not connect a board like this. I actually connected a lamp, and that's where the second stage of the attack comes in, because we're going to install this board or USB device inside another USB device. So you can pretty much weaponize any USB device like a USB lamp, a Hoover, a joystick, a game controller, or whatever you really want. The steps that we're going to show you are pretty generic and should work on most USB devices with some modifications. So there's two steps to this attack. First, we're going to have to prepare the Arduino board, and in the second stage, we're going to embed it in a USB device. So I'm going to show you how to prepare the Arduino device myself, and then my best friend Adrian is going to show you how to embed this Arduino board in a lamp. But like I said, you can use the steps to weaponize pretty much any USB device. So for step one, you're going to need, first of all, to have the code that you want to execute on the target system. And like I said, we're going to be starting with this code. If you don't understand what it does, please watch this video because I explain it in details in the video. I literally explain what each statement does. So I'm not going to talk about it in this video. you're going to need to come into this website right here. I will include it in the description of the video. I won't be including my website. I won't be including this link. Please go and check it on Zsecurity or on YouTube, because some people report links like this. It doesn't really affect us because they give us the channel back, but it just delays us. So I'm not going to include this link, but I will include this link right here. This website will convert the script that we have in here to an Arduino program that we can run on the Arduino board. So you simply have to paste the script here, click on the run compiler, and it will result into the script that you see here on the right. We're simply going to copy all of that. And finally, you're going to need to download the Arduino IDE. This is the program that allows us to compile and send the script that we just created here to the Arduino board. So you can download it for Windows, Linux, or OS X. Download the one that is compatible with your computer. And once you have it downloaded, you will be able to run it. I have it right here running. And using this program is very, very simple. First of all, we're going to paste the script that we just copied. So I literally pasted the script that I got from here. We have it right here. The next step is we're going to need to connect the Arduino board to the computer so you can compile and upload this program to it. We're going to go to Tools, Port, and make sure the Arduino device is selected. And we can see that it is selected right here. You can also see that the device type is Leonardo, the board type. So when you go to the board in here, you want to make sure that you select Leonardo. You will also need to install an extra library, which is this library right here, the HID project. So you're going to have to go to Sketch, Include Library, Manage Libraries, type the library name in here. So HID project, highlight it and click on Install. As you can see, the install for me is grayed out because I've already installed it. Once you're ready, you want to close this and you want to go to Sketch and Upload, or click CMD and U to compile it and upload it to your Arduino board. Give it its time right here. As you can see right now, it's saying it's done uploading. It will actually reset once it's done, so you'll see it writing some commands, and you can see it's actually writing the commands that I have in my script. So that basically just means everything is working properly. And that's it. So now my Arduino board, let me just go back to the diagrams. This board right here is fully programmed and ready to be used. And when it's connected to a computer, it's going to tell it that I am a keyboard. It's going to execute all of the commands that I gave it, which will basically download and execute a backdoor, and it'll send a reverse connection to my hacking machine. I have my web server already running on the hacking machine because this script right here will actually download the backdoor from my hacking machine. And I'm also already listening for incoming connections so that when it's executed, I can receive the connection and control the target and then do whatever I want to do on it, as I showed you earlier. So now that we're done with this, the next step is going to be embedding this Arduino board in the USB device. And this is where I'm going to hand it to Adrian to show you how to do that.
Hello everyone, this is Adrian from Zsecurity. Today we're going to install an Arduino board in an LED desk lamp. But before we do that, I'm going to walk you through the tools that I'm going to use today. So here we have a soldering station. It looks a bit intimidating, there's bits of it missing. It's just a 75 watt output soldering iron. You can use something lower, but this will be much quicker than that. Here we have a tip cleaner. So, some cheap flux that you can just get on eBay. A brand new tip for my soldering iron because my current one is on the way out. A Phillips head screwdriver that we're going to use to take apart the lamp. Some solder wire, just lead-free Rosen core wire. A wire stripper that will allow us to remove the insulation from the wiring. A wire cutter and some alcohol so we can clean up the flux. So now that we've seen the tools that we're going to use today, let's open up the lamp and get to work. To begin with, there are 4 foam pads, which you can see in here, and 4 Phillips head screws that are installed in each one of the corners. Once we've removed them, we can take apart the lamp. And the top part is connected to the printed circuit board. This is for the main LED light, this here. And there's another wire that is soldered here which is for the capacitive switch that allows us to turn the lamp on and off. So once we've done that, we can get to the main printed circuit board. Now this is it has two main solder joints connected to the USB cable. So we desolder these two with some wick and the soldering iron, and we can pull off the board. Now you can already see that I've extended the white and the green wire. These are the data plus and the data minus for USB communication. So one of the main challenges with finding a good device to implement this with is not every device is going to have data lines. Most of them will only have the red and the black wire, which are positive 5 volts and ground. So in some cases, you're actually going to have to replace the wire so that you can have these extra cables. You can already see that I've double-sided taped the Arduino board that we're going to use. You can also see that I've added some tape onto the LEDs so that the device still remains stealthy while it's plugged in. So next, we're going to add the circuit board back to the wires that we desoldered, and we're going to add the extra wires to power our Arduino board. Okay, so I'm going to resolder these two main points here. These power the board, and we're also going to attach power for our Arduino. And on the final assembly stage, I'm also going to resolder the switch, which was connected here. The two wires that I'm going to use are just generic small wires, small gauge wires that we're going to attach to the Arduino to power it. First of all, I'm going to connect my two power cables so that I can supply power to the Arduino board. Okay, so I'm going to apply a little bit of flux onto the points.
So why do you apply the flux?
Flux cleans the joint and allows the solder to spread nicely. So we're going to tin the tip and get to work.
So this is for the power?
Yeah, this is the ground point, and this is the positive point, which is here. There we go, those look nice. Ish. Okay, so the main points are resoldered, so the board should work on its own now. Now we need to power our Arduino. So to do this, we're going to take two wires. I'm going to start with the negative wire. I'm going to strip the end of it. Apply a little bit of flux. And solder it. Pre-tin it so that it's easy to attach. Then attach it to the negative point here.
So this wire is still not attached to anything on the other side, is it?
No, it's not yet attached to the Arduino.
Okay.
We're just starting by attaching it to the main power source. And so we're going to do essentially the same thing with the positive wire, where we're going to flux it. And apply some solder. And then solder it onto the main power source. Trying to do it without melting the other wire, of course. And there we go. Okay, so now I'm gonna do the same to the other ends. I'm gonna pre-tin them. Okay. Now we're gonna start connecting it to the board. So the blue wire, which is our ground, will go onto this first pin here.
And how did you know this goes on the first pin?
Well, I do have a diagram that's sitting right beside me, which we will share with our people, with our viewers.
So did you look it up on Google and found it?
Yeah, it's just a standard USB pinout. So every USB device is pinned out this way. Connect the power wire. Now it is important to not bridge any of these, because if we do, the device will be damaged. Alright, so there's the power and the ground.
Wait. Yeah, perfect. Now
They look decent. Next up, we need to prepare the two data lines. Just as we did before, we're gonna strip the ends and tin them with solder.
So right now you did the power.
Yeah.
And we're gonna do the data.
So right now the Arduino and the light will function. They will turn on. However, the Arduino is not going to communicate with the PC until the two data lines are soldered.
Perfect. And the data lines, these are the cables that you had to add yourself, obviously.
Yeah, so generally USB devices like this, like lamps, will only come with two wires built into the main wire, the power and the ground. Now the wire we've added to this unit has all four. It has the two data lines and the power and the ground.
Perfect.
So the green wire will go beside the blue wire.
Again, you're getting all this from the diagram.
From the diagram that is right beside me. Yes. There we go, looks good. We'll do the same with the white wire. Just need to position it a little bit better. And that's it for the main connection part. Now all we need to do is make sure this is safe, that there's no bridges, that nothing will touch against anything, so there's no short circuit when we plug it in. And after that we just reassemble the lamp itself.
Can you give us a review of what you've done so far? So just a big picture between the connections. Which board is the new board? Which board is the old one? Like what came with the lamp and how, you know, the extra wires, everything you've done basically.
Okay, so this is the main board that was shipped with the lamp. These two solder points here, these this is the negative point, this is the plus 5 volt wire that we can solder onto.
So that's the power?
Yeah, this here, the red one is the power, the blue one. I should have used black, but there wasn't any black handy. This is the ground. Here's the Arduino board with the ATmeGA32U4 chip and the 4 connections that we made, which are ground, data plus, data minus, and positive 5 volts. Okay, so now that we've finished soldering the connections, we should clean off the flux off the board. Flux that's left on the board can cause corrosion and all kinds of issues that we don't want to deal with. Alright, looks good. Next up, we're gonna secure the board with we can either re-weld these plastic pins or we can use some hot glue, and then we're gonna attach the main LED back onto it. And reconnect the battery. So now, as I mentioned before, we're gonna need to resolder the switch wire that turns the lamp on.
And like the steps you've shown are kind of generic, so they should work on any device. You will have to adapt it depending on how the inside of the device is. But mainly you want to connect power and you want to connect data. Absolutely, yeah. Those are the necessary prerequisites for our Arduino to interface with a computer. Cool.
So this one's easy enough because there's already solder on this wire. There we go, it's dry. And that's it. Now we reinstall the screws, put it back together, and check if it still works. Or check if it works. Yeah, check if the lamp still works at the very least. So I'm gonna turn it on. And it still works.
Perfect.
I haven't broken it. That's a success. Okay, so the main steps to accomplish this are quite generic. You can extend them on two other USB devices. Essentially what you need is power and ground for your Arduino, and also the two data lines, which will allow it to communicate with the computer. Hope you enjoyed it. This has been Adrian from Z Security. Subscribe, like, whatever.
Now, if you're a programmer or considering to learn programming, then I highly recommend checking out Kite. It's an add-on that you can add to pretty much any IDE or text editor, including Sublime, which is my favorite, and it'll pretty much transform it into an IDE, showing you function signatures, documentation, possible methods, and so on. But the coolest thing about it is it'll study your programming style and use machine learning to auto-complete your code. It's really, really cool. You have to try it to see it for yourself. Just use the links in the description to get it. Kite is sponsoring this video, but I wouldn't recommend it if I didn't like it and didn't use it myself. That's it for this video. I hope you found it useful. Don't forget to like it if you liked it, and subscribe to the channel to stay updated with the latest in cybersecurity.